Hi all, good morning, good afternoon, good evening, wherever you are. My name is Vishnu Dutt, and in this video, we are going to talk about transmission control protocol from scratch. Okay, so first thing first, what is the motivation to create this course? The first motivation was that a lot of my students, many of them, whenever they go out for the interview, right? They freak out when these companies ask question about transmission control protocol, right? Or the TCP. Believe me, this protocol looks complex, but it is not. Okay. So first motivation was this. Second motivation was that even on the workplaces, right? We are, if you consider myself, I'm a network engineer, right? So generally, most of the network engineers are pretty good. They are pretty good with respect to layer 2, which is the data link layer. They are pretty good with respect to layer 3 also, right? Where we talk about OSPF, BGP, and then some of the stuff, routing stuff, the cool stuff, right? But when it comes about transmission control protocol, we sometimes we have a kind of a blind spot there, right? So generally, whenever there is a problem in transmission control protocol, we say that it's a problem of application, right? So this was a second motivation that although we are pretty good with respect to network layer, we should take this responsibility of transmission control protocol also. Okay, so having said that, here is the agenda for today's session. So first thing first, what we are going to talk about here. If we understand why at the first place any protocol has come into picture, then basically we come to know more about it. We can learn it pretty easily. And most of the times means whether we talk about software defined WAN, whether we talk about software defined access, if we understand why behind it, believe me, we are going to get this technology or any technology with ease, right? Second thing is whoever develops TCP, right? Doesn't matter. We are human beings. We take examples from real life, right? So we are going to take example from real life to understand how TCP is solving some of the problems when two computers talk between each other. Believe me, TCP is just a protocol who is doing uh, basically the efficient work how two computers can communicate with each other, right? This is a protocol which efficiently solve this problem. Okay, so we will take example from our real life. How do we communicate as a human being, right? And then we will take these example and talk about more uh, uh, with respect to TCP/IP. So first thing first, we are going to begin with why TCP. We are going to spend some good amount of time here. Then we will talk about how do we communicate, right? What are the things which we take care when we communicate? Then the major thing, we are going to talk about how two computers talk over the TCP, right? And in the starting three topics, we are not going to discuss much about the terminology, right? But terminology is important. We are going to learn the concepts from real life, and then we are going to implement in TCP. But we need to give them some name or some terms, right? Which is already there. So we will be learning in today's session only that what are those terms and terminology. Okay. I'm not sure how much this session is going to be, how much long this session is going to be, or this course is going to be. But believe me, if you spend some good amount of time learning this course, the problem or fear with respect to transmission control protocol is not going to be there. So this is my promise. So if you complete this course, the full course, maybe 6 or 7 hours, uh, you are good, pretty good with respect to transmission control protocol. There won't be any hesitation when you are explaining TCP to somebody or when you are attending some interview. Okay, so having said that, let's try to go behind why. right? Why at the first place TCP is needed. So we are going to go spend some good amount of time in learning why TCP. Okay. Having said that, let's move to the new board, right? So why TCP? As you can see, I have drawn here TCP IP model, right? You all know that this model contains 5 layers, which is very simple. Physical layer, which talks about the actual medium where we are going to send our data, right? The data link layer, where if we are talking about Ethernet, we are talking about MAC addresses over it, right? How encapsulation is happening here, the data link layer. Network layer, again, we are pretty good, right? Because we talk routing protocols here. Here is the blind spot, and here we have the application layer, right? So in most of the scenarios, in most of the organization, even in some of my project also, okay, uh, whenever there is a problem, means something with respect to application is not working. For example, a user is there and he is saying that he is not able to access application, and the application experience, it's pretty bad. So, as a network engineer, I'm going to check that whether we have a sort of good routes in our routers, right? And I can right jump into the OSPF, BGP, whatever protocol we are learning there, and we can solve the problem related to OSPF or BGP issues, or maybe any routing protocol, whatever you are learning here, right? If there is a layer 2 issue, I can right now jump there and then basically resolve it, right? So generally, most of the times what happens, a user comes to you or it opens a ticket, right? If you are in the operations, and he says that I'm not able to access application number one, right? You do not know the problem. So you just check exactly in which subnet this application is there. Then you go and check your routers and switches to see whether you have exactly that route available or not. If the route is available, you can go and check for the firewall guys also, that whether they have done some activity because of which we are not able to access this application, right? As simple as that. But and if you are good with respect to your end, means all these 3 layers are working fine, you say it is not my problem at all, right? Then you say it is a problem of application guy, right? So application guy is just responsible for the management of these application or the servers on which these applications are running. So he goes into the server, he says the memory required for this application is pretty good, right? My server is running great. I do not have any problem. So he straight away say, no, it is a problem of the network guy, right? But believe me, sometimes, and I have seen a lot of times, the problem is right there, right? We network engineer do not take the responsibility of transport, so as the application guys do not take the responsibility of transport. So how this problem is going to be solved, right? Generally, what we do, we just take a packet capture, right, from our side, or and then we send it to application guy. Application guy doesn't care about it, right? So who would be solving this problem if there is a problem at the transport layer? I would say, as a network engineers, let's take one more responsibility. Let's take a responsibility of one more layer. Okay. So believe me, if you do that, it is going to be good. And one thing I want to make sure, right? This protocol is not difficult at all, right? But you need to go step by step. And this protocol is not the one which you can learn in maybe half an hour or 1 hour. You need to spend good amount of time. I have seen a lot of videos are there. No problems with respect to them. And some of them have explained TCP well. But believe me, if the video length is only 8 or 9 minutes or 10 to 12 minutes, basically you are not going to get all the concepts of TCP, right? So I am always a big supporter of whenever you're learning something, just spend time. Even if you're watching this video, just have a cup of coffee with you, right? And while having that coffee, just watch this video because it is going to be long. Just spend some time, okay? And then the concepts are going to be good. So first thing first, why TCP? Because nobody is going to take the responsibility of transport layer, right? Why you want to learn TCP? Because there must be somebody who needs to solve this problem of transport layer. And because we have a good understanding till network layer, there is no harm in just extending ourselves to one more layer. And it is my job to make this transport protocol look pretty easy for you, right? So I would like to take the example again. We haven't finished with why TCP. We are just saying that why we are learning TCP. As a network engineer, we are learning TCP because nobody is taking responsibility of TCP, right? Which is at the transport layer. So let's move towards one more board where I'm going to discuss why exactly this protocol or the transport protocol is important. Okay, so let's take an example from real life where we have two characters. Okay, so I have taken an example from Indian names, right? There is a girl named as Anjali, and there is a boy named as Rahul. They are going for a date, suppose, right? They are on a date. So in this date, basically, they are pretty happy, and Rahul has just said to Anjali that he loves him. Okay, and he is expecting an answer from him. So Anjali got a shock that although she was on a date, but yes, but she wasn't expecting these three words from Rahul. So she informed Rahul that. Uh, I need some time. Okay, I need to think first thing first, and then I'm going to reply today over the internet. Maybe I will be calling you, or maybe I will be using WhatsApp to inform you, right? So here is the scenario, right? And you must be thinking that why this guy is talking about all this nonsense. Believe me, there is a proper reason. If you understand all the things and I'm going to take the example of these two characters, Anjali and Rahul, and believe me, they are going to teach you the nitty-gritties of transmission control protocol. Okay, so having said that, we understand the scenario. Rahul has proposed Anjali, and Anjali is saying that I will be responding to you today, maybe in the evening time, right? And over the telephone. Okay. So what happens next? Here you go. So right now, Anjali has decided that she is going to talk to Rahul and going to respond Rahul on WhatsApp or maybe any other application, right? Whatever is used. So to understand the importance of TCP, what I've done in this TCP IP model, right? There is no transport layer at all. There is no transport layer here, right? And if we do not have transport layer, then we are remaining with only four layer, which is application, from which we are going to take the data. And then we have network layer, right? And then we have data link and physical as usual. And in the middle, we have this internet where a lot of the routers are there in the middle, right? So I think you understand that what we are going to do, right? What we are doing here is we have just eliminated the transport layer from the TCP model, TCP IP model. And then we want to see that what is going to happen or what can happen, what miscommunication can happen if there is no transmission control protocol or there is no transport layer at all in TCP IP. Okay, so Anjali decided that she's still now still do not doesn't want to go into the relationship. So he types a few words there that she types, I don't love you, say, right? And uh, she's using this WhatsApp application. So for the better understanding, I'm saying that whatever she is writing is a packet, right? So this application basically where she is writing, and there is a layer which is the network layer just behind this application because there is no TCP now. So from application, network layer is receiving whatever application is sending, right? At the network layer, we see that we have packets, right? So I don't love you is the message written by Anjali to Rahul, right? On an application, maybe it's a WhatsApp application or any other application. Network layer just receives these four packets, right? And you all are network engineers. You are pretty good with respect to network layer. You take all these packets, whatever are coming from the application, right? And you just need to see the what is the destination IP address configured on these IP packets, right? And you are pretty comfortable. You are just sending these packets to data link layer, which is going to send these packets out to the physical layer. And then we have these routers on the basis of the source IP address and the destination IP address, sorry, the destination IP address. These routers are going to forward this packet. So these eventually are going to receive at the Rahul's end, right? And then again, the reverse process happens. These packets are going to data link, then network, and then basically to application, right? But as you all know, network layer is a connectionless protocol, or if we talk about IP or the internet protocol, it doesn't create any connection. It takes the data, right? And on the basis of destination IP address, this IP protocol is going to send all these packets, whatever we are receiving, right? So what exactly happens? Suppose we are at this router R2, right? And the traffic path which is going to be there, which this internet has decided from Anjali to Rahul, I am showcasing you with this yellow color. It is like this, suppose, right? So basically we have these three routers in middle, and here we go. We have this traffic path, okay? So suppose at this router R2 is facing some congestion. Okay, so the meaning of congestion is it is not able to forward all the packet which is it is receiving, right? So it is receiving some of the packets, and but because of the congestion of the uh, interface, it is not able to forward some of the packets, right? So suppose the packet I is forwarded. Packets love is also forwarded. Packet U is also forwarded, but the router 2 doesn't forward this zone, right? All the packet reaches here at the physical layer at the Rahul's end, except the word or the packet which contains this word don't, right? What is the message received at Rahul's end? The Rahul is going to receive the message which say I love you, and this guy is just overwhelmed, right? Because whatever because he received the message, but is this message is correct? No, absolutely not, right? There is some routers, the router number R2, which was facing congestion, right? This router just drop one packet, and because of that packet, there is a whole lot of confusion now, right? What we are doing here, we have just eliminated the transport protocol or eventually the TCP, right? And because of that, because network layer doesn't care, right, whether the packet is dropped or not, it just take the packet from the application, whatever application is sending me, right? It is going to forward this to data link layer, and then data link layer going to forward it via the physical layer to other routers and switches. So so most of the times means whenever I am teaching to college graduates, I ask them where this TCP model is implemented, right? And believe me, most of the times I don't get the answer correct. So to all of you who are new into the TCP IP protocol, believe me, the TCP IP stack or the TCP IP software is everywhere or on all the devices which are able to communicate using internet, right? So if I say I have a mobile phone, which is right here, this TCP IP model is implemented right there into your mobile phone. If I say I have a laptop or I have a PC, this TCP IP model is implemented there also, right? If I say I have a router, then this router also have implemented this TCP IP model, right? So if somebody says that this router is a layer 3 device, it means that a router can understand till layer 3 of the TCP IP model. It means that it understands physical layer, it understands data link layer, it understands network layer. But although the definition is not correct in today's world, because routers are also quite intelligent and they can understand till application layer, right? But generally, we say router is a layer 3 device. What is the meaning of it? The meaning is that router can understand the starting. If you're starting from the bottom, then basically it can understand physical data link and network, right? If I say a switch can understand till layer 2, it means that it only understands physical as well as data link layer, right? So why I'm telling all this information? I'm telling all this information because this router have also implemented TCP IP model, but it can understand till layer 3, right? So it takes the packet whatever is sent by Anjali. It is forwarding that packet to Rahul towards Rahul. Okay, but here is a lot of confusion. Anjali is saying I don't love you, and Rahul is getting the message that she loves me. Okay. So there is a whole lot of confusion created just because we do not have TCP, right? Sometimes if you want to understand any concept, then just sometimes you can get it understand better, right? If you feel that what is going to happen if that concept is not going to be there, and we have taken the same approach. What if there is no TCP? What if there is no transport protocol, right? Or transport layer? Then basically we are going to see such kind of problem because network layer just take the packet, just send them out, right? It doesn't care whether my packet is received at the other end or the not, right? So with this communication, it is pretty evident that we are missing something, right? This is not the communication. This is not the correct communication, whatever we are going on. We are not uh, implemented something correct, right? And that is why basically we are having such discrepancies between Anjali and Rahul. It's a problem. We need to solve it. And that is why this TCP is coming into picture, right? Can you guys suggest me what can I do to just solve this problem, right? And believe me, means I have asked this question from many of you, many guys, and they straight away simply said that why don't you just mark these numbers? Why don't you just mark these packets? So this packet is packet number 1, this packet is packet number 2, this packet is packet number 3, and this packet is packet number 4, right? So what is going to be received by Rahul? Rahul has just received packet number 1, packet number 3, and packet number 4, right? It means that what is missing? If I send all this information to Rahul, Rahul can straight away say that or application which is running on Rahul's mobile, right? It can straight away say that the packet number 2 is missing. And if the packet number 2 is missing, I should not inform this information to Rahul, right? It is as simple as that, right? So, and believe me, this concept is nothing but the concept of why you have implemented sequence number in your transmission control protocol. But I do not want to go into the terminology. I just want to make you understand that this protocol is not difficult at all if you understand why behind it, right? If we do not have transmission control protocol, there is no way we can track our packets. So most of the guys says that why can't we implement all these things in application layer itself, right? Whenever I send something to network layer, I can just mark these packets as the number, right? But believe me, there are a lot of application because you have WhatsApp application, right? You may be having Telegram, you may be having Gmail or whatnot, right? So if these applications take care of this responsibility of delivering the data end to end, then each and every application need to implement the transport layer in the application itself, or whatever the duties of transport layer in the application itself, right? We do not want to have this duplication of work, and that is why there is a need of protocol which should solve all these problems. Okay, I think I'm able to make my point at least that if we do not have TCP, then the communication between two parties maybe it is not going to be correct communication, right? If we just trust the network layer, believe me, it is not going to be uh, the correct communication, right? Okay, having said that, let's move towards our next board, and there we are going to take an example from how do we communicate, right? So now till this point